Hello, Ferdinand here. Welcome to the second part of the Cinema 4D C++ SDK for macOS tutorial series. And in this part, we're going to build the SDK. So we're right at where we stopped in the last part. So we generated our build system, or configured and generated our build system. And we did this here in this folder, built Xcode, and we're now going to have a look at our project structure. So here's our build system we generated, and before we look into the build system, it's important to point out that CMake, other than, for example, Xcode itself, or for example, Visual Studio, so many IDEs, or also our project tool, it does not mix your project files or the generated files with the manually created files. So all the automatically generated files will be put into this build system folder, and when we look here into the plugins folder, which is how the SDK ships the source code, you'll find here the source code. So other than, for example, like many edits will do it, it will not put here things like project files or build fragments into your project. So therefore you do not need these built-in functionalities of IDEs like clean solution of Visual Studio or clean project from Xcode. When you basically want to bring your project into a vanilla state with no project files or all the other fluff which is generated by a build system, you can just delete this build system folder and then just keep all your source code changes and configuration changes, and continue working like this. And the other advantage is, of course, you can have multiple build systems side by side. So you could have here, of course, also Windows, so an MSVC build system, and Visual Studio Clang build system. You could also have your Linux build system, but more importantly, you can have here also multiple Xcode build systems side by side, which, for example, could do different things, and that's not possible when you put your project files directly into your project. So let's have a look at this Xcode folder. First of all, we see here our SDK structure a little bit reflected. So we also have here a frameworks folder, and we also have here a plugins folder. As I already told you in the last video, this plugins folder can be configured, for example, with the custom path files, or you can also set this to a different folder. So your source code or your project actually don't have to live here in this SDK folder. They could be scattered over the whole system. But for the build system, it will always put them here into a folder called plugins. And we see here our modules/projects reflected. So here's also an example assets folder. But other than this folder here, it will not actually contain the source code and your project files and the resources, but it will contain the generated configurations. The same is basically what happens here for this frameworks folder. This does the same for your frameworks. What's also important is here the C4D/SDK or -SDK Xcode project folder. This contains for Xcode build system here the project file. So basically the file which is opened when we click here this button. What is also here in this folder is this binary for this bin folder. This is not yet populated, so we populate it once we build actually things. And what also will be populated when we build things is this generated folder. So Cinema 4D has something which is called the source processor. This is meta-programming tool which generates source code based on the source code you wrote, and this automatically generated code will be placed here in this generated folder. We will also have a brief look at this when we build things. So now let's switch to Xcode. And so the first thing we have to do, so by default will be here some projects selected. And what we have to do when we want to build things is select the all build target, because if we would leave here this schema selected, so this is this selected schema we have, and we would press here play, or in other words build, then it would just build here the, in this case, the Xcode framework, and we of course want to build everything at once, so we have to select the all build target. And another thing which we should do is we should have a look at the schema. So this is here basically the same thing. If you go into products, you can select here the active scheme, and we have here the all build scheme selected, and we now click on edit. And here we see the configuration of this build target, and we can see this has the build configuration debug at the moment. And we ship the Cinema 4D SDK with two build configurations, namely debug and release. And in case you're not aware, a debug configuration basically means that there's additional metadata compiled into the binaries which help you debugging them. So you have more debug information at runtime. This is of course very helpful for debugging your plugin, but you should never ship a debug binary to customers, because debug binaries are much slower than release binaries. So this is not a small difference, this is a really substantial difference. So you should never ship debug binaries to customers. And when you want to ship to your customer, you should select here this release configuration, but we will now build the debug configuration because we want to later debug the SDK. Yeah, and this is all you have to do. You just click the now play here and or build, and then you can see here the project start building. Now we click here on this icon here on the right, and then click here on example build there. This is the ongoing build, and have a look at the build output while it's building. So first of all, we can see it's building here the framework. So for example, the Xcode framework we just talked about a second ago. Unfortunately, it didn't finish building it, but it finished building here the core framework already. And what we can see at the end, it says create a static library libcore framework.a. So this is basically what I talked a second ago about. So these frameworks are being compiled into static libraries. This libcore framework.a is the static library here. And if we go a little bit down, here is the example hello world. So let me open this. So here there's an example hello world plugin module being built, and this will be built into a dynamic library for which we do not yet see here the output. I will show you this later. So how this basically works is it builds, so it starts building the things in your project, and the plugin modules will be compiled into dynamic libraries, which are then loaded by Cinema 4D at runtime. And in order to build these dynamic libraries, it builds these frameworks as static libraries, which represent the API of Cinema 4D, and your plugins then link against these static libraries so that they can then interact with Cinema 4D later. And one last thing is what we also can see here are these lines where it says here, for example, for the core nodes framework, run custom shell script, generate, and so on and so on. And then, for example, generates here this file. And this is exactly the source processor about which I talked a second ago, which is running there, which is automatically generating source code there in the course of the build process. We'll also have a look at that in a second when the build process is done. Okay, I'm now going to cut the video until the building is done. See you in a second. Okay, so the build finished now. We can see this is roughly how long this took here. And you should have here this build succeeded message, and you should have here no build errors. If you have build errors, you will see them here in your build output. And now we're going to have a look at what changed in our project. So we again have here our SDK folder, and we have here our Xcode build system. And just as a reminder, we have here our source code in this project in this plugins folder. And here's, for example, this example asset folder. And Cinema 4D or its build system works like this, that you have what Cinema 4D called modules. So this is a project which will be a module. And these have here these project folders, which have here this project definition file, which basically contains the configuration of this project. And each of these folders, which has this project folder and this file, will be compiled into a binary. So in a dynamically linked library, or a library which is basically loaded at runtime by Cinema 4D, which is then quote-unquote a plugin, but actually is what Cinema 4D calls a module, and this module could contain multiple plugins, and they are compiled into binaries. So, and we have here this bin folder, which we already saw before, and we have here the subfolder debug, which now contains content. And if we go back here to Xcode and go here into our all build scheme again. And remember, we set here as a build configuration debug. So we build here debug binaries. If we would have set this to release, and then we would have here also a bin/release folder with the same folder structure, and it would contain then the release binaries. And just as here for this other plugins folder, we also have here this libs and plugins folder, and this plugins folder reflects the content of this folder. But as already explained before, we could also name this folder foo, for example, or we could scatter its content over our whole system. It will then always be reflected as this plugins folder when then all modules are collected. So we have here these two folders, and the first folder is this libs folder, and this contains the static libraries about we already talked while Xcode was compiling. So here are all the static libraries for the frameworks against which these plugins have linked. So you don't really need them anymore. So they're of course still needed for when you want to build again, but you don't have to ship them to your customers. So they have done their purpose now. And if we now look here into the example assets folder, we see here two things. First of all, we see here this example assets.xlib, and this is the actual plugin binary which is here. So this is the debug version, and but this is what macOS natively calls a lib, but Cinema 4D calls its DLLs or dynamic libraries always a little bit differently on each system. And this is xlib is the format which plugins have on macOS. And what's also here in this folder is here this res folder, or more, to be more precise, a symbolic link to the resource folder, which is to be found here in this in our actual source code folder. And this contains the resources. So in the case here of example assets, there are some dialog resources and string resources and the symbols. And module binary expects its resources to be placed next to it in a rest folder, and that's why there's here a symbolic link to this folder. And if you want to ship, you shouldn't ship this because it's a debug binary, but if this would be a release binary and you want to ship this to a customer, you would basically have to copy this file and this folder and put this into a folder and zip this, and this would be then the plugin you could ship to a customer, and they could just then load with Cinema 4D. Yeah, and that's pretty much already it. So we have here this bin folder, and this basically contains the build output of your build system. What we can briefly also have a look at is this generated folder. And this generated folder contains the output of the source processor about which we talked a minute ago. So we can, for example, look here again to the example assets, the output for the source processor for the example assets project, and the output is here always in these HXX folders, and you can see the source processor creates a lot of files. Most of them do not contain much content, but as you can see, for example, this one should contain a little bit more content, and these are the automatically generated source code, which basically makes our API work. The source processor is more important for the Maxon API. So there are two APIs in Cinema, the Cinema API and the Maxon API. And you, in the beginning, will mostly work with the Cinema API, so the source processor is there less important. But it will always run both for Cinema API and Maxon API projects. And the reason why I'm telling you this is because when you make some mistakes, it could be that in your build errors you will then see files like this register HXX pop up, or something like the interface registration CPP. There's an error, and then you know where those files come from. They're automatically generated for your project. You never have to edit these files yourself. So because first of all, they're in the build system, so they are meant to be volatile or automatically generated. So if I would edit here this file, this would be overwritten the next time I'm compiled, so it's pointless. So you cannot fix the files themselves, but when an error appears in these files, this usually means you made an error in your files, and therefore the meta-programming mechanic doesn't work. But in the beginning, when you deal just with the Cinema API, you usually don't have to worry about this. Okay, this concludes the part about building the SDK. I hope this helped and you sort of understood how this all works. I hope I will see you in the next part. Happy coding and happy rendering.